My name is Landon, and my project was on a constant of mass. So I hypothesized that if I made the right formula, I could define a quantity that would be constant in terms of mass, kind of like the mole, but a little bit different. So what I did was I came up with this, which is mass divided by atomic mass times AMUs, right? An AMU is an atomic mass unit. Mass is a quantity of matter, and MA stands for atomic mass, which we all know on the periodic table, right? So that gave me across the board a value of 5.97 times 10 to the 23rd. Very similar to moles, but a little bit smaller. Moles is 6.022 times 10 to the 23rd. It's more specific and overall is just more accurate, which is an interesting thing. And in the end, it proved my hypothesis right, that you could quantify a common or quantity of mass among all things, which is kind of interesting. But more specifically on this, if you take AMUs out of this and you just take mass divided by MA, you get the number of atoms in a thing, which is really cool because you can have two completely different values, because hydrogen, for instance, is going to have a lot more atoms in the same amount of grams than lead is, because there are a lot more protons and neutrons in lead than there are in hydrogen. So you'll have different quantities of this thing, which is density. But if you then divide it or times it by AMUs, you get a common value, because of the structure of AMUs is the atomic mass of those things will equal a common value, basically, which is really interesting. If you go even further, if you could find a common volume among all atoms, you could, theoretically speaking, find a common density, which might be due to state of matter, but is less important, because if you have a common mass and a common volume, you'll end up with a common density, which is a really cool idea. But yeah, that's the sum of it. The testing on it was mostly just doing some math, and that's what proved it. There's not a lot of data to go along with it.